Everyone have their notes? Ready to go? If you were not here, shh. Sam, notes. Samuel. Notes. No, not you. Sam, get your notes up. Okay. So guys, listen, remember, as I'm taking attendance and stuff, you guys should be ready for me when I'm done doing all my stuff. So, as a reminder, I was not here Friday. If you weren't here, I will get you the worksheet. The key is on Canvas. If you weren't here on Thursday, I gave out a new pink sheet. I will give that to you. A couple of you weren't here on Thursday. Today, we're finishing up 1.2. Short amount of notes. Homework will probably fit within the class period. Okay. And then tomorrow, I won't be teaching anything new. It's a quiz review day. I have a worksheet review. That's going to be very similar to the quiz, okay? Also, tomorrow is your first homework check, which I'll explain how we do that tomorrow. And then Wednesday is the next quiz. I have not forgotten, just so you know, about that last quiz some of you want to retake, so hold tight. I will be forthcoming with that. Let me, so I told some of you I'd show pictures of my daughter getting engaged, so I'm just going to share. It's so sweet. She did. You might notice she's wearing a white dress in this picture. So when she was getting ready, I was like, that's a cute dress. Well, I asked her later if she knew that he was going to propose, and she said she had an idea. So she knew she had this dress on the ready for when they I don't like seeing them kiss. Yeah, this isn't West Palm Beach or Palm Beach, Florida, but that's the happy couple. They're super cute. But she didn't know she knew I was in town. Obviously, I was staying with her. No, there's a professional photographer. No, I can't take a picture. Saved my life. So I was stalking her. She didn't know I was there yet at the thing. So she was like being funny with her ring and like all that. And then that's right before, because I was like recording, doing a video actually, all the way up to her. She didn't even know I was there the whole time. So, and then she turned around and we cried together. It was nice. So yeah, she said yes. She was not surprised. Bummer, but you know, that's what happens when you pick out the ring yourself and you've been together forever and all that stuff. Anyway, so now I have to plan a wedding. Next stress is helping her plan this wedding. All right, here we go. So most of what we're doing today is review. There's not much in here that's brand new. But so really what we've been talking about is behaviors of graphs, and we'll go deeper into that, and AROCs, right? Average rate of change, also known as slope, right? M. There is something called an instantaneous rate of change, and I kind of don't like that it's brought up here because we're not going to find it. We can't. At this level of math, it's impossible to find an instantaneous rate of change, and I'm going to explain what that means. Instead, what we do is the average rate of change. So let me just show you what I mean by instantaneous. So on this graph, just looking at this graph, it's a curve, okay? If I asked you, what's the slope right at that point right there, you would say, I can't determine it. Guys, please don't talk. So, because if I wanted to find what the slope is just right there, I would only have one x value, because it's just 1 point. So think about your formula for slope. Your formula for slope, if you want to write it down again, or AROC, is the change in y on top over the change, oops, sorry, that should be an x, the change in x. And remember, you can change the order. You can put y first on top, and then you would have to remember to put x first on the bottom. But this is nothing new, finding the slope between 2 points. But on a curve, we have to have 2 points, because think about it. If I only have 1 point, my denominator would be 0, right? If my x value is just 5 minus 5, I would get a 0 in my denominator. You can't ever have a 0 in your denominator. So when you get to calculus, you'll be able to find instantaneous rate of change at any 1 point. What we do is we find the average rate of change between 2 points. And as a reminder, this is a review of what we did last Thursday, is this is asking us to find the AROC between 1, 2, 3, 4 different sections of the graph. We're just going to do one. We don't need to do it 3 different times. But remember, this notation is an interval, given intervals. These are x values, x sub 1 and x sub 2. This is not an ordered pair, okay? What we're looking at here is 1 comma something, we don't know what it is yet, and 1.1 comma something. We don't know what it is, okay? So what we need to do is find the y value at each of those points, and then we just plug right into the formula, okay? And use our calculator to get the AROC, slope, whatever, okay? So on Thursday, we had 3 different ways of doing it, of finding these. Sometimes, like this example, our least favorite, by the way, we have to actually do a little bit of arithmetic by plugging 1 in for t and 1.1 in for t and finding the y value. Other times, we can use a graph and just pull ordered pairs off the graph. Love it when that happens, right? There's my x, there's my y, I just plug into the formula. And then there's a third type, which is if it's a table of values. Sometimes you have a table of values, and you can just pull the x and the y out of it. So it's basically 3 different ways we've seen it done. Algebraically, which is what we have to do now, a graph, or a table of values. So to find those y values, I have to plug in. So if I plug in 1 into that equation, everywhere I see an x, which is known as t in this problem, I would put a 1 and use my calculator to simplify that. So this would be negative 16 plus 48 plus 120. You guys can just trust me. I put that in my calculator and I will get 152. We'll do the second one in our calculator together. I get 152. So h of 1 is 152. X is 1, y is 152. Okay? Let's do h of 1.1. Now, like I said, none of this is difficult. It's just annoying, right? You have to plug numbers in, pick up your calculator, make sure you get your negatives right and everything. We like it much better when we can find the slope using a graph or something, because the points are right there given to us. So whenever I have to put numbers in my calculator in an equation like this, I'm always going to take control of order of operations. In other words, in doing this math here, I have to do my exponent first. So I'm going to do 1.1 squared and then times negative 16. And that gives me negative 19.36. And then 48 times 1.1 would give me positive 52.8 plus 120. And then I would just type that in my calculator, left to right, negative 19.36 plus 52.8 plus 120, 153.44. Okay, now I don't need to see this. I'm just making a point, okay? Like you could just find your y values. I mean, you have to find them somehow. I'm showing you. This is what our 2 ordered pairs are. So just like you did in Algebra 1 and Algebra 2, you plug these numbers into the formula. Now we did it a little fancier, so let me remind you of how we did it. So we said AROC is, I'm going to use H, but if you accidentally wrote F, I wouldn't mark it wrong, okay? Because we're so used to using F as our letter, but in this one they used H, so we'll just do that. Now remember, the order doesn't matter. I'm going to do the second one first. So H of 1.1 minus H of 1 over, so I'm going to maintain that order, 1.1 minus 1. You can skip this step in the homework, but I want you to get comfortable seeing it. This is like, being very complete with all of our work. Then we can plug those numbers in. H of 1.1 is 153.44. H of 1 is 152. And when I do that in my calculator, I'm going to get 0.1, and then the rest is just calculator work. Yep. Nope, that's what I just said. If you don't want to do that step in your homework, that's fine. I want you to just be comfortable seeing it and knowing what that language is, okay? It's really, really, really important that you know when you see this right here, that represents what is y when x is 1.1. That's what you want to know. Okay, so put this all in your calculator and you should get 14.4 feet per second. Now, I didn't read the whole word problem, but this represents the height of an object t seconds after it's launched. So it's it's rising 14.4 feet per second at that particular interval, okay? Now, if we had found the interval, this interval, or any other, it would be different. Remember, it's always changing on a curve, okay? So on this exact piece of the graph, this is the speed that the object is going up, because it's positive. If it were negative, it would be going down, okay? All right. So I kind of already talked about this. In this course, we can't find instantaneous. We find average. So let's look at this next example. We're going to use our calculators to graph a few different functions, and we're going to say, is the average rate of change over the interval that they give us positive or negative? That's what we're answering the question with. So we'll come back to that when we have the graph on our graphing calculator. So if I were you, I would go ahead and clear your RAM. Second plus 712. I probably only have to keep giving that to you for a week. Some of you might have already memorized it, but that is a great thing to do when you first start class each day. Okay, second plus 712. Just right in a row. Second plus 712, and it should say, RAM cleared. Help your neighbor if they're struggling. Everybody okay? No, clear. Okay, go to y equals, thank you, darling. Go to y equals, and we're going to put in x squared. Okay? We don't have to graph it. We let our calculator do it for us. So x is right here. And there's a quick button for squared. You can hit squared if you want to, but also you could have used your caret button and hit 2. Okay? So x squared, and then hit graph. Just hit graph. So it's a parabola, right? It's a parabola, the parent function, the most basic graph. Now, we don't need to zoom and play with our window. I mean, you could go to your table if you were struggling and see what is happening from 2 to 3, but I'm sure you can kind of tell. 2 to 3 is over here somewhere, right? Here's 2, here's 3, approximately. Who cares if I'm off a little bit? The same thing is happening this whole piece, right? This whole segment. Is the slope, is what it's asking. Do we have a positive or a negative slope right there? It's positive, right? Think back to what you learned in Algebra 1. When a line is rising left to right, going up, that's a positive slope. If it's falling left to right, it's a negative slope. It's the same thing. We can't say that about the whole graph. We only can talk about a piece of a graph when the graph is curvy like this, okay? So on this exact piece, our slope is positive, right? Go back up to y equals, and we don't have to clear our RAM here because we didn't change the window or the zoom. We didn't mess with all the settings. So if you you can clear your RAM, it doesn't hurt anything, but it's faster just to hit your clear button. If you just hit clear, it just takes it out of there for you. And now, and again, we'll get into logs. You don't have to remember how to graph a log right now. Your calculator knows how to do it. Here's your log button, log. And then I'm going to put an X in where it is. Now, you can close your parentheses if you want to, but when you're going to hit another command, like enter or graph, it knows to close it for you. But it doesn't hurt. If you wanted to close your parentheses, that's totally fine, but I'm not going to bother with hitting another button if I don't need to, and I'm going to hit graph. Now, this graph is actually, I know it's hard to see, but this is what these look like, okay? Don't worry about it too much. You don't have to have the exact graph. You should be able to tell, though, where is 0.01 to 1. I don't know. It's somewhere right in here, right? Who cares? Somewhere in here. Who cares? I'm off a little bit. And even here you can tell. Without having to mess with all my settings, waste a bunch of time, is my slope positive or negative right there? Positive. right? It's just visual. You're just looking at it. If you went to the table of values and changed it to count by this, you would see the numbers are getting bigger. They're growing in both of these. The y values are getting bigger, so you can see that it's growing, but you don't need to. It's visual. Let's just do one more. Y equals clear. And you can use 0.5 here to save yourself a few buttons, but I'm going to put it in as a fraction just to show you fractions. We are going to use our division key as our fraction button on these calculators. Works exactly the same, but you must always put fractions in parentheses. Okay, so it's 1 divided by 2 in parentheses. That's 1/2. Okay, fractions are division. And then just use your exponent button, which is right here, and then put in x. It's 1/2 to the x. Graph. What is happening from -1 to 0? What's happening right there? We are decreasing, slope negative. Yes. Okay, so that's enough of those. But you get the idea. You can tell if the rate of change is positive or negative visually with a graph, okay? I'm not doing this whole example, but I want to talk to you guys about the tangent line. So back to this curvy graph, you can draw what's called a tangent line at any point. So at this point right here, we just talked about this a little bit ago, that we can't find the instantaneous rate of change at that point. We would have to have between 2 points, right? We need 2 points, and then we just find the average between them. That's what that formula is that we use, the AROC formula. It's the average, the slope formula, okay? But at any point on a curvy graph, you could draw what's called a tangent line. It touches the curve at 1 point. You could have one, you have one over here too. You could draw one right here. You could draw one right, and they're not perfect. I don't have what's that called? A ruler out. I'm just kind of sketching it. But these are called tangent lines. They touch a curve at 1 point. And what we could do, which we're not going to, we've been doing it, we just haven't really talked about it like this, is using 2 points on that line to find approximate average rates of change. Okay? So this last little bit that we're going to talk about is a lot of what's on your quiz. So you're going to get it covered right here and a lot on the quiz review tomorrow. So once I'm done with this, please, if you have any, once you start the homework, any questions you have about any of this stuff, please come back. Call me over. I just walk around and bother you for the rest of the period. Okay, so what we're going to be talking about the rest of the notes is just being able to use these words correctly to describe behaviors of graph. So behavior means, like, you remember end behavior, what's happening at the ends of a graph. What do we know what's going on? Okay, so, and what's confusing about this concept, not difficult, okay, it's just we have to clear the fog a little bit. What's confusing is that we use positive and negative and increasing and decreasing to mean different things depending on if we're talking about just the graph or the rate of change of a graph, okay? So here's some ways to describe rate of change of some graph, okay? We don't even see it. If the rate of change is positive, that means the graph is increasing. That's what that means, right? We talked about it. If the rate of change is rising from left to right, meaning it's positive, that means the graph is going up on that segment. So negative, of course, would be decreasing. You can abbreviate, totally fine. It's DECINC. Okay, now let's just muddle the waters a little more and talk about rate of change using these words. Completely different concept. Whenever we're talking about rate of change increasing or decreasing, this is concavity. Concave up, concave down. So remember, this is concave up, little shortcut there. This would be concave down. And I taught you a little trick to help you memorize this, and it has to do with the letter D If you are concave down, your rate of change is decreasing. So this would be a concave down section of the graph. And it's increasing on concave up. You might remember this picture. I love this picture because I really feel like it helps you understand what I'm talking about there. If a graph is concave down, the slope between any 2 points will always be decreasing as we go left, right. We start at 2, we end at -2. Concave down, it's decreasing rates of change. If it's concave up, it's increasing rates of change. Remember, down and decreasing. So concave up is the other one. There's only 2, right? So if the rate of change is increasing versus decreasing, we could talk about concavity. Let's put that all together with this picture. The graph of G is shown at the right. Complete the statements below. So this is where we're putting it all together. The graph, we're not talking about the rate of change yet, just the graph, just looking at the picture. Is it increasing or decreasing? Increasing. It's getting bigger. Remember, we always read left to right. It's increasing. And it's concave what? Is this graph concave up or down? Up. Right? Visual. Just looking at it, we can tell those two things. Okay? Now, let's talk about rate of change. Because the rate of change of this is what? Is this rate of change positive or negative? Positive, because it's increasing. The rate of change is also increasing. It's concave up, right? That's increasing. This is really putting a lot of that stuff all in one problem. And we're going to do one more example of that, okay? Putting all this together. I love this problem, this example 9 right here. This is life. This is everything, okay? This is what a lot of your questions are going to be like on the quiz review and the quiz. So let's go through it. You're given a picture, graph of F. The graph, and it'll lead you a little bit more like multiple choice or whatever. But is this graph, so we haven't talked about this for like a week. Is the graph positive or negative? Not the rate of change. Is this graph positive or negative? Positive. Why is it positive, people that said positive? It's above, nope, not, it's above the x-axis. That's it. All the points are positive. There's no negatives. The graph is positive, not the rate of change, not the slope, okay? The graph is positive. Is it increasing or decreasing? Now you're scared to answer. Decreasing. The graph is going down, left to right. Okay? How about the slope or the rate of change? Is the rate of change positive or negative here? Negative. It's going down. That means the slopes will all be negative. Is it increasing or decreasing? The rate of change. When I say it, that's bad teacher talk. Is the rate of change increasing or decreasing? Concavity. This is concave what? Up. So what is the rate of change doing? Increasing. That's confusing, right? Everything we said, it looks like it's going down, it's decreasing. But remember, concavity, rate of change is going, since it's concave up. I think we all understand that, right? We all understand that that's concave up. You have to memorize concave up, rate of change is increasing the whole way on concave up. It's increasing. So remember, that's the other one. Down is decreasing. D's are easy to remember. This is the other one, okay? All right, is this graph positive or negative? Negative. It's below. All the points are below. It's a negative graph. Is the graph increasing or decreasing? Increasing. It's going up, left to right. Okay. Is the rate of change positive or negative? Positive, because the graph is increasing. It's getting bigger, so we know that these are all going to be positive slopes. But is the rate of change increasing or decreasing? Decreasing, because this is concave down. So rate of change is decreasing. It's confusing. Yeah. It's confusing, okay? This is what we have to really focus on and understand the differences. It is confusing. They keep crossing all these words together. Again, separate in your brain. Are we talking about the graph or are we talking about the rate of change? It's two separate categories of descriptions, okay? We'll do more of that tomorrow. Today, your homework, A6, practice set 2, are just these 5 problems, okay? Label your homework. Remember, you don't ever have to say, write all that out. You're never going to turn homework into me. It's going to stay in your binder the whole year. So if you don't want to waste time with it, don't worry about it. But you can if you want to, right? So just these problems. Even though my key always has all the answers, you skip the ones I don't ask you to do, unless you want to do them, okay? But this is all I would check if I checked this homework assignment. It's just those problems, okay? Now, 14 is the mean one. 14 is the worst one, but it's also not, okay? I want to remind you, and I think every homework problem is just finding a rock. More of plugging into that formula. Guys, listen, I'm almost done talking, I promise. Just plugging into the formula. Like number 14, the points are right here. You don't have to plug in anywhere. These are the points, A, B, and C. So you're finding a rock 3 times, but you don't have to plug in. But then when you get to like 16, that's just pulling off of the graph. 17, though, you have to plug in, just like we did in our first example. So just notice the differences in the problems. But it's the same math over and over and over again. Okay? All right. I can fit all of the key up here. Watch me. It just takes me an hour to do it, but I can do it.
Yeah.
Welcome back, Fernando. You were not here for their question, right? Who else? Caitlin. You were asking. It's always around a 3 decimal places. 3 decimal places is what we do on all of our tests. It says 3 places. I'm at 0.967. I'm kind of white out over it.